Differential and integral operations 4, and now we're going to prove this identity A cross curl B is gradient B dot product with A minus A dot gradient del operator acting on vector B using the subscript summation notation. So for this purpose, let's start with writing this cross product using subscript summation notation. It's a cross product between two vectors. So we have epsilon ijk, aj, k component of the second vector, which is curl b k component in ei hat direction. And now we're going to open up the curl of B, epsilon ijk, aj. How do I write the k component of curl B? It is epsilon klm del bm del xl. So the del operator L component and B vector M component in I hat direction. Now we have the product of two Levi-Civita symbols, so we can use the Levi-Civita identity. To do that, we must have the K index in the same position, so KLM can be written as also LMK using these cyclic permutations. So we can write, instead of KLM, epsilon LMK. Now they're in the same position. AJ del BM del XL in EI hat direction. Okay, and now we can use the Levi-Civita identity. Kronecker delta, first indices are I and L. Kronecker delta IL. Kronecker delta second indices JM minus Kronecker delta inner indices JL. Outer indices IM. AJ del BM del XL in EI hat direction. So that's what we have here. Okay, now we're going to operate the Kronecker delta. Kronecker delta sets L is equal to I and M is equal to J. So we're going to have AJ, and for del BM we're going to have del BJ, and for del XL we're going to have del XI, because L will be equal to I in EI hat direction. And then for the second term we're going to have J is equal to L, so let's make this one L. Del BM will be made I, BI, del XL in EI hat direction. Okay, and now we can take this EI hat here, try to recognize what we have. We have AJ EI hat, del BJ, del XI, minus, and now for AL, I recognize that this is AL EL hat, that's vector A, dot product with derivative with respect to XL EL hat, that's acting on vector BI EI hat. All right, so that I have EL hat dot EL hat is 1, and I obtain this, which means for this I can write similarly AJ EJ hat dot product with EI hat. Now I can recognize this EI hat del xi. This is the gradient operator. Dot product with the gradient operator acting on BJ EJ hat. So that this will give me this is going to give me 1, and then I have EI hat remaining. So EI hat is part of the gradient operator. Okay, so that's taken care of. And here I have vector A dot product with the del operator acting on vector B. Now I can recognize this part. Gradient operator, del operator acting on vector B dot product with A minus A dot product with gradient acting on B. Now you have to recognize that this is a gradient operator acting on vector B. There is another way to write this. We can say that this is the del operator. This is the del operator acting on B only in the dot product A dot B minus A dot gradient B. So this B indicates that it only acts on B components, not on A components. So that's another way to say this. And this came from basically AJ gradient operator acting on BJ. So this part, so let me clarify what that means. So AJ I have gradient operator acting on components of B. This is AX multiplied with gradient operator acting on BX plus AY multiplied with gradient operator acting on BY plus AZ gradient operator acting on BZ, etc. So that's how I concluded that this gradient operator is only acting on components of vector B and not on vector A. So this is giving me a vector here for gradient of A dot B, but gradient with respect to B only, minus A dot gradient acting on B. So going back to the identity we were supposed to prove, A cross curl B is gradient operator acting on B dot product with A minus A dot gradient B. So this is a vector, and this is also a vector. And you can see that this gradient operator acting on B there's another way to say this. It's basically the gradient operator with respect to components of B acting on A dot B. And the second term is minus A dot gradient operator acting on B. Okay, so we started out by writing the cross product A cross this vector epsilon ij k e I hat, j component of the first vector, k component of the second vector. Now k component of the curl is epsilon k lm del del xl bm. So for epsilon ijk, epsilon klm, I can also write epsilon ijk, epsilon lmk because we have cyclic permutations here. And I can use the Levi-Civita identity epsilon il, epsilon ijk, epsilon lmk is Kronecker delta il, Kronecker delta jm, first, seconds minus inners jl, outers im. Then I set L is equal to I, so that's what I have here, and M is equal to J, that's what I have here, AJ del BJ del XI EI hat, and here I set J is equal to L, and M is equal to I, del XL EI hat. Now I have to recognize what this is. So since I have the J index here, this means I have a dot product between these two. So this is AJ EJ hat dot product with a gradient operator, because this EI hat del del XI is the gradient operator acting on components of B, BJ, EJ hat. So that's basically EJ hat dot EJ hat is 1, so I'm left with this term. So this means this is gradient acting on components of B dot product with A, or in other words, this is the gradient operator with respect to B acting on A dot B, only on components of B. And the second term here is AL and del del XL, that implies a dot product here as well. AL EL hat, dot product with del del XL EL hat, acting on BI EI hat. So this is A dot product with the del operator multiplied with B, or acting on B. So here I have A dot gradient B. Therefore, my final answer is gradient B dot product A minus A dot gradient B. Only here I have to be careful. This ends up being a vector as well, because what this really means is it's a gradient with respect to B, as we have shown here explicitly. This for each component here, I have J going from 1 to 3, X, Y, and Z. I have AX multiplied with gradient of X component of B plus AY gradient of B component, Y component of B, and Z component of B, etc. So this is our end result. So let's rewrite it here. We have A cross curl B equal to gradient with respect to components of B, A dot B, minus A dot gradient B, or it's the same thing that was written in the problem statement.